Good morning everyone. Myself Aishwarya Sujit Prasad Dikshit from BSc third year. My topic is crystal field theory. Let's start. The topic contains crystal field theory, postulate of crystal field theory, shape of d orbitals. Crystal field theory. This theory involves an electrostatic approach to bonding in complex. It was first applied to ionic type crystalline substance. Therefore, it is very often called the crystal field theory (CFT). Crystal field theory was proposed by Hans Bethe and J. H. van Velde in 1930s. This theory considered the metal ion being placed in electrostatic field created by the surrounding molecule or ions. The electric field changed the injuries of the d electron in the case of transition metal ions. Many of the properties of complexes are related to these changes. This assumes that the bonding between the metal ion and ligand in complex is purely ionic. The crystal field theory was proposed a little earlier than valence bond theory, but it took about 20 years for this theory to be used by chemists. In 1951, many theoretical chemists working independently used crystal field theory in the spectra of complex of the d block elements. The crystal field theory (CFT) is an electrostatic model which considered the metal ligand bond to be ionic, arising purely from electrostatic interaction between the metal ion and the ligands. The essence of theory is that the 5d orbitals, which are degenerate equal in energy in the free gaseous ion of metal because differentiate into level of different energy under the influence of electrostatic field of the ligands. In order to apply this model to transition metal complex. Postulates of crystal field theory. This theory considered a complex as a combination of central ions surrounded by other ion or molecule with electrical dipole called ligands. It regards these ligands as point charges or as point. Example, the negative ligands like Cl negative, Br negative, F negative, Cl negative, etc. are negative point charges, and the ligands like H2O, NH3, CO, etc. are as negative point. The bonding between the metal cation and ligands occurs due to the electrostatic attraction between the nucleus of metal cation and partial negative charge present on ligands. Thus, the bond between metal and the ligands is purely ionic. Third point, the interaction between the electron of the cation and thus of ligand is entirely repulsive. This repulsive force are responsible for the splitting of d orbitals of metal cation. Fourth point, in its simplest form, the crystal field theory does not consider any overlapping between metal orbit and ligand orbitals. Fifth point, the d orbital which are degeneracy destroyed by the approach of ligand during the formation of complex. Shape of d orbitals. Let's discuss with the d orbital shape. How many orbital d subshell of these 5d orbitals? dxy, dyz, dzx, dx square minus y square, dz square, these 5 orbitals. Shape of the orbitals is very important to understand the shape of d orbital. If you to understand crystal field theory only of the shape d orbitals, we can understand and explain crystal field theory very effective. What is the shape dx and y orbitals? Electron density is not x and y axis, that is present in principal axis xy. This is dxy plane. Electron density is not present in principal axis. that is present in between principal axis. dx dy z electron density present between the x and y, in between the y and z, in between the x and y. But remember, electron density is not present on principal axis. dxy, dyz, dzx, all these three orbitals having some same behavior, their electron density present in between the principal axis. But in case dx square minus y square, electron density is not present in between. Electrons density is present along b axis axis and x axis and y axis. Electron density is exactly on the principal axis. You will find, if you rotate dxy orbitals around z axis at an angle 45 degree, you will find dx square minus y square and z dz square. It is also having electron density on principal axis. Remember how of these 5 orbitals are having electron density in between the principal axis, and these 2 orbitals having electron density on principal axis. Based on this ability of electron density, they will differentially in case of transition metal complex is when a ligand approach to the central metal ion and central metal ion electron present in these orbitals. In which orbitals electron is present, which orbital directed towards ligands, the interaction of raising of energy of how much splitting be there, that will depend on the interaction of the ligands with the orbitals of the central metal ions. Thank you.